Yes, we are continuing, and so far we have reached to what we call the properties of alkanoic or carboxylic acids. Now we are going to look at what we call the physical properties, and here we are going to narrow it down to what we call the ethanoic acid. But generally, we are looking at their chemical properties, and here we say the first 10 straight chain alkanoic acids are what? They are liquid, and that means they are liquid where at room temperature. So room temperature is 25 degrees Celsius. So at this temperature, we are saying that these straight chain alkanoic acids, all of them are liquids. But when we look at the lowest members, such as methanoic and ethanoic acids, this one here, they're soluble in water. So that means if you have your water in the test tube and you mix this one with water, you will not like differentiate. You will not have like separate layers. Just like the mixture is going to be miscible. Then we have this MB, we are saying the solubility of alkanoic acids generally decreases with increasing what? Molecular mass. So therefore, if I have that one of carbons, okay, if I assume the carbon atoms are 3, then I have that one of carbon atom 6. So that means this one with carbon atoms 3 and the other one with carbon atom 6, this one is having what we call a high molecular mass compared to this. So therefore, this one is less soluble in water compared to this one with C3. That's the meaning of this statement. The solubility of alkanoic acid generally decreases with increasing molecular mass. So the higher the molecular mass, the less solubility of these alkanoic acids. That's why when we look at these lower members, methanoic acid and ethanoic acid, for them, they become miscible with water when you mix them. But when you keep increasing the chain, you will see that the solubility keep on decreasing. Then NB2 is that the boiling points and the melting points of these alkanoic acids increased because of one, we have the hydrocarbon length. So the hydrocarbon length here we are saying like this one of CH3, CH2, CH2, and we continue. So the moment this one is increasing, this is what we call the hydrocarbon length. If it is increasing, so that means the boiling point and the melting points of these specific molecules is also increasing. Why? Because in these hydrocarbon chains of the length, there are forces, and those forces we call them the intermolecular forces of attractions or van der Waals forces of attraction. So they hold the molecules together. That's why when you try to boil them, or when you try to at least reach their melting points, you will see that they are high. So we also say there's this formation of hydrogen bonds between the carboxylic acid molecules, and it is brought about by what we call the partial positive and the partial negative charges on the hydrogen and the oxygen atoms of this functional group. So these charges enable these molecules to attract each other to form what we call strong hydrogen bonds, and structurally we can see it in bonds. So this one can be illustrated like this structural in this way, and we say here we have oxygen, of course, and here we shall have oxygen being attached to hydrogen. Then here we have the R, which is the alkyl group. Then also let's say we have another one like this, and here we say the alkyl group, and down here we'll have oxygen atom. Then also this side I'll be in position to have this oxygen also attached to this. So here is where we shall see, this one here we shall have the partial negative, and this one here is the partial positive. On this one also we shall have the partial negative. Then on this atom, we shall have the partial positive. So therefore, there is this interaction. So we are saying this one, the partial negative and the partial positive on these atoms, they try to attract each other to form what we call the strong hydrogen bonding. So these are what we call the hydrogen bonding. So shall be in position to say this is strong hydrogen bonding. So that's how we can explain that thing structural. So this thing, when they're in solution, you will see them in that format.